We realize that when we put water on the surface of a hot saucepan, it changes phase into vapor immediately with a pop sound. This is the reason why when we cook things like scrambled eggs, it is important not to leave any water on the top of the saucepan. Unlike water, oil can be heated without any vigorous changes in its physical form, which allows the food to be heated stably at a relatively high temperature. We hypothesize that this is because oil has a much higher latent heat of vaporization compared to water. To compare the latent heat of vaporization between water and oil, we use a data logger with a temperature sensor and measure the change in temperature of water and oil over time. And we have some marvelous results. According to our results, it takes more than 10 minutes to vaporize 100 grams of olive oil compared to 2 minutes for 100 grams of water. Furthermore, the boiling points for olive oil is 310 Celsius degree, almost 3 times of the boiling point of water. The extremely high boiling point and heat capacity prevented oil from vaporizing in a short period of time, which made oil a much better heat conductor between food and the pot.
When we try to quantitatively explain the boiling point and latent heat of a substance, we need to evaluate the intermolecular force between the molecules. There are 3 kinds of intermolecular forces: van der Waals force due to the attraction between the instantaneous poles, dipole-dipole force due to the attraction between the permanent poles, and hydrogen bonds, which is a special form of dipole-dipole force between hydrogen elements and other elements. Usually, we refer to nitrogen, oxygen, and fluoride. So among 3 forces, hydrogen bond is the strongest, which means that it requires the most energy to break. For example, water contains hydrogen bonds, so its boiling point and latent heat are relatively very high. So according to the molecular structure, a hydrogen bond does exist between the oil molecules, which means that oil will have a very high boiling point, almost 300 Celsius degrees, and a very large latent heat, which also make it a very nice medium for cooking.
The molecular properties of oils also lead to important health implications in the realm of biology. Unsaturated fats are fat molecules with carbon double bonds. Unsaturated fat molecules help reduce the level of LDL cholesterol, which stands for low-density lipoprotein. LDL cholesterol contribute to plaques that can lead to the narrowing of artery, heart attack, and strokes. Saturated fats are fat molecules with no carbon double bonds. Saturated fat raises the level of LDL cholesterol and increases the risk of the diseases related to the circulatory system. We compared the saturated fat and unsaturated fat of olive oil, coconut oil, palm oil, and blended oil. We hence illustrated the following bar chart. It shows that olive oil and blended oil has high level of unsaturated fat and low level of saturated fat. In coconut oil and palm oil, it appears the level of saturated fat is much higher than the unsaturated fat. Hence, we concluded that comparing to consuming coconut oil and palm oil, consuming blended oil and olive oil are more likely to benefit health by reduce the risk of having diseases related to the circulatory system.
This part represents you the design of the bottle and how this project relates to science. This bottle is made of plastic and plastic only. It's not appropriate using a metal bottle as the container because olive oil will have a chemical reaction with metal. Plastic is cheaper than glass, so which make plastic is a better option as the material. The bottle is commercially attractive because it has a very high aesthetic value.